The National Electrical Code, or NEC, Article 449.109. B requires emergency stop buttons for air handling units, or AHUs, serving patient care or critical care areas in healthcare facilities. NEC Article 530.13 requires emergency shutoff within sight of electrical equipment. However, this provision does not explicitly mention AHU. Regarding force protection requirements, information regarding specific requirements for emergency stop buttons for AHU and force protection requirements documents could not be found. However, the following resources may be helpful. Department of Defense Manual 4270.1. H. Physical Security of Department of Defense Controlled Installations and Facilities. This manual provides guidance on physical security measures for Department of Defense facilities but does not specifically address emergency stop buttons for AHU. The Interagency Security Committee, or ISC, Framework for Infrastructure Protection, provides guidelines for protecting critical infrastructure, including buildings and heating, ventilation, and air conditioning systems. However, it does not directly address emergency stop buttons for AHU. Additional considerations include the Life Safety Code, or NFPA 101, which may require emergency stop buttons for AHU in certain occupancies, such as healthcare facilities. ASHRAE Standard 62.1 recommends emergency stop buttons for AHU that serve spaces with high occupancy or critical operations. Local codes and regulations may also have requirements for emergency stop buttons for AHU. It is always best to consult with local authorities and relevant building codes to determine the specific requirements for emergency stop buttons for AHU in your jurisdiction. The NEC, specifically Article 449.109. B. Mandates emergency stop buttons for AHU in healthcare facilities serving patient or critical care areas. This is a critical safety measure to quickly shut down the system in case of an emergency. NEC Article 530.13 mandates emergency shutoff within sight of electrical equipment. While it doesn't directly address AHU, it's a relevant consideration for electrical safety. The Department of Defense Manual 4270.1. H. offers guidance on physical security for Department of Defense facilities, but does not provide specifics on AHU emergency stops. The Interagency Security Committee, or ISC, Framework for Infrastructure Protection provides guidelines for protecting critical infrastructure, which includes buildings and their HVAC systems. However, this document also doesn't have specific information regarding emergency stop buttons. The Life Safety Code, NFPA 101, may require emergency stop buttons for AHU depending on the occupancy type, particularly in healthcare facilities. This is dependent on the specific requirements outlined in NFPA 101 and should be reviewed for your application. ASHRAE Standard 62.1 recommends installing emergency stop buttons for AHU that serve high occupancy spaces or critical operations. This is more of a recommendation, but it's a good practice for enhancing safety. Be sure to consult local codes and regulations because they may have specific requirements for emergency stop buttons on AHU in your specific location. They will differ based on jurisdictions. Firstly, determine if the AHU is located in a healthcare facility serving patient care or critical care areas. If so, NEC 449.109. B applies requiring an emergency stop button. Secondly, consider if the AHU is within sight of other electrical equipment. NEC 530.13 might apply, requiring an emergency shutoff means. Thirdly, check if the facility is a Department of Defense controlled installation. DoD Manual 4270.1. H provides physical security guidance, though not specifically for AHU emergency stops. Fourthly, review the Interagency Security Committee, or ISC, Framework for Infrastructure Protection for general guidelines on protecting critical infrastructure. Fifthly, check NFPA 101, the Life Safety Code, to see if it requires emergency stop buttons for AHU based on the occupancy type. Sixthly, consider ASHRAE Standard 62.1, which recommends emergency stop buttons for AHU in high occupancy or critical spaces. Seventhly, always consult local authorities and building codes to determine specific requirements in your jurisdiction. Eighthly, emergency stop buttons should be easily accessible and clearly labeled. Ninthly, ensure that the emergency stop button shuts down the AHU completely, including fans, heating, and cooling. Tenthly, regularly test the emergency stop button to ensure it functions correctly. The purpose of an emergency stop button is to provide a means to quickly and safely shut down the AHU in the event of an emergency situation. This could be a fire, a chemical spill, or any other event that requires the immediate shutdown of the system. The emergency stop button should be located in a readily accessible location such as near the AHU itself, or in a central control room. It should be clearly labeled so that anyone can easily identify it in an emergency. When the emergency stop button is pressed, it should immediately shut down all components of the AHU, including the fans, heating elements, cooling coils, and any other associated equipment. This will help to prevent the spread of fire, reduce the risk of exposure to hazardous materials, and minimize any further damage to the system. It is also important to regularly test the emergency stop button to ensure that it is functioning properly. This should be done at least once a year or more frequently if necessary. During the test, verify that all components of the AHU shut down immediately when the button is pressed. If any problems are identified, they should be corrected immediately. In addition to the emergency stop button, it is also important to have other safety measures in place for AHU such as fire dampers, smoke detectors, and automatic sprinkler systems. These measures can help to prevent fires from spreading and to protect occupants from smoke and other hazards. Properly installed and maintained AHU are essential for providing a safe and comfortable environment in buildings. By following these guidelines, you can help to ensure that your AHU are operating safely and efficiently. Now let's delve into some more detail about the specific codes and standards mentioned earlier. The NEC Article 449.109. B is very specific about healthcare facilities. It's not just any healthcare facility, but those serving patient care or critical care areas. This means hospitals, intensive care units, and similar locations where the health and safety of patients are paramount. The reasoning behind this is clear. In such environments, a malfunctioning AHU could have dire consequences, potentially disrupting vital medical equipment or spreading contaminants. That is why the NEC mandates an emergency stop button to enable immediate shutdown in such emergencies. Next, we need to carefully read NEC Article 530.13. It states emergency shutoff within sight of electrical equipment. The key phrase is within sight. If the AHU has electrical components that need to be shut down in an emergency and those components are visible, this article might apply. For example, if you can see the AHU electrical panel from a particular location, an emergency shutoff might be required at the vantage point. It's not as direct as the requirement in 449.109. But it's an important consideration. The Department of Defense Manual 4270.1. H is focused on physical security for Department of Defense facilities. It covers a broad range of security measures, but as we noted earlier, it doesn't specifically call out emergency stop buttons for AHU. However, this doesn't mean you can ignore it completely. You should still review the manual to see if any of its general security principles apply to your AHU installation. For example, it might contain guidance on securing access to the AHU room or on preventing unauthorized tampering with the equipment. The Interagency Security Committee, or ISC, framework for infrastructure protection provides a broader perspective on protecting critical infrastructure. It is focused on buildings and their HVAC systems. While it doesn't directly address emergency stop buttons, it emphasizes the importance of risk assessments and security planning. You can use this framework to evaluate the potential risks associated with your AHU and to develop a comprehensive security plan that includes emergency shutdown procedures. The Life Safety Code, NFPA 101, is another important document to consider. It focuses on life safety in buildings and it might require emergency stop buttons for AHU depending on the occupancy type. For example, NFPA 101 has specific requirements for healthcare facilities, assembly occupancies, and other types of buildings. You need to consult the relevant sections of NFPA 101 to see if they apply to your specific situation. AHU Standard 62.1 is not a mandatory code, but it's a widely recognized industry standard for ventilation and indoor air quality. It recommends emergency stop buttons for AHU in high occupancy spaces or critical operations. This recommendation is based on the idea that these types of spaces are more vulnerable to emergencies and that a quick shutdown of the AHU can help to mitigate the risks. Even if it's just a recommendation, it is a good practice to incorporate this into your design. Now let's emphasize the crucial point: always consult local codes and regulations. The NEC, NFPA 101, and AHU Standard 62.1 provide a foundation, but local jurisdictions often have their own unique requirements. Your local building codes might be more stringent than the national codes, or they might have specific amendments that apply to your area. It's essential to check with your local building officials to ensure that you are complying with all applicable regulations. Aside from complying with regulations, it's also important to think about the practical aspects of emergency stop buttons. Consider these points when designing and installing them. Firstly, the emergency stop buttons must be easily accessible. Don't put them behind locked doors or in obscure locations. They should be readily available to anyone who needs to use them in an emergency. Secondly, the emergency stop buttons must be clearly labeled. Use a standard symbol or wording that everyone can understand. Make sure the label is durable and won't fade over time. Thirdly, test the emergency stop buttons regularly. Don't wait for an emergency to find out that the button is not working. Conduct regular tests to ensure that all components of the AHU shut down immediately when the button is pressed. Fourthly, integrate the emergency stop button with other safety systems. For example, if you have a fire alarm system, consider linking it to the AHU emergency stop button. This way, when the fire alarm is activated, the AHU will automatically shut down to prevent the spread of smoke. Fifthly, train your staff on the proper use of emergency stop buttons. Make sure everyone knows where the buttons are located and how to use them. Conduct regular drills to practice emergency shutdown procedures. By addressing both the regulatory requirements and the practical considerations, you can ensure that your AHU emergency stop buttons are effective in protecting people and property. Remember, safety is not just about compliance. It's about creating a safe environment for everyone who uses the building. To summarize, let's highlight the key takeaways. Firstly, understand the specific requirements of NEC Article 449.109. B. If you have an AHU in a healthcare facility serving patient care or critical care areas. Secondly, evaluate the applicability of NEC Article 530.13 based on the visibility of electrical equipment associated with the AHU. Thirdly, review the Department of Defense Manual 4270.1. H. If you are working on a Department of Defense facility. Fourthly, consider the Interagency Security Committee or ISC framework for infrastructure protection for a broader perspective on security planning. Fifthly, consult NFPA 101, the Life Safety Code for occupancy-specific requirements. Sixthly, consider AHU Standard 62.1 for recommendations on emergency stop buttons in high occupancy or critical spaces. Seventhly, always check with your local authorities and building codes for specific requirements in your jurisdiction. Eighthly, ensure that emergency stop buttons are easily accessible and clearly labeled. Ninthly, regularly test the emergency stop buttons to ensure they function correctly. Tenthly, train your staff on the proper use of emergency stop buttons and emergency shutdown procedures. By following these guidelines, you can create a safer environment in your building. In addition to the points already covered, it's also essential to consider the potential consequences of an AHU malfunction or failure. This can help you to determine the appropriate level of safety measures, including the need for emergency stop buttons. For example, If an AHU failure could lead to a loss of critical cooling in a data center, the consequences could be severe. In this case, it would be prudent to install emergency stop buttons and to implement other redundant systems to ensure continuous operation. Similarly, if an AHU is located in a hazardous environment, such as a chemical processing plant, the consequences of a malfunction could be catastrophic. In this case, it would be essential to implement a comprehensive safety plan that includes emergency stop buttons, fire suppression systems, and other safety measures. When assessing the potential consequences of an AHU failure, it's important to consider not only the direct impacts on the building and its occupants, but also the indirect impacts on the surrounding community. For example, if a hospital loses power due to an AHU failure, the consequences could extend far beyond the hospital walls. Patients could be put at risk, and the hospital's ability to respond to other emergencies could be compromised. Therefore, it's essential to take a holistic approach to safety planning and to consider all potential consequences of an AHU failure. It is important to look at maintenance and testing. Regular maintenance and testing of AHU are crucial for ensuring this safe and reliable operation. This includes regular inspections, cleaning, lubrication, and replacement of worn parts. It also includes regular testing of emergency stop buttons and other safety devices. A well-maintained AHU is less likely to malfunction or fail, and it's more likely to respond correctly in an emergency. Therefore, it's essential to establish a comprehensive maintenance and testing program for all AHU in your building. This program should be based on the manufacturer's recommendations, as well as any applicable codes and standards. The program should also include regular training for maintenance personnel on the proper procedures for inspecting, cleaning, and maintaining AHU. Furthermore, it's important to keep accurate records of all maintenance and testing activities. These records can be used to track the performance of AHU over time and to identify any potential problems before they become serious. They can also be used to demonstrate compliance with applicable codes and standards. Remember that safety is an ongoing process. It requires continuous monitoring, evaluation, and improvement. By staying informed about the latest codes, standards, and best practices, and by implementing a comprehensive safety plan, you can create a safer environment for everyone who uses your building. Always remember to document your work. Thorough documentation is essential for any AHU installation or modification. This documentation should include detailed drawings, specifications, and calculations. It should also include a record of all inspections, tests, and maintenance activities. Proper documentation can help to ensure that the AHU is installed and maintained correctly, and it can also be used to troubleshoot any problems that may arise. Furthermore, documentation can be invaluable in the event of an emergency. It can provide responders with critical information about the AHU, such as its location, configuration, and operating parameters. This information can help responders to quickly and effectively shut down the AHU and to mitigate any potential hazard. Therefore, it's essential to maintain accurate and up-to-date documentation for all AHU in your building. Store the documentation in a safe and accessible location, and make sure that it's readily available to authorized personnel. In addition to the technical aspects of AHU safety, it's also important to consider the human factor. People are often the weakest link in the safety chain, so it's essential to train them properly and to provide them with the tools and resources they need to do their jobs safely. Make sure that all personnel who work with AHU are properly trained on the potential hazards and on the proper procedures for operating and maintaining the equipment. Provide them with regular refresher training to keep their skills sharp. Also, encourage them to report any potential safety hazards or concerns. Create a culture of safety in your organization where everyone feels empowered to speak up and to take action to prevent accidents. By addressing both the technical and human aspects of AHU safety, you can create a safer environment for everyone. Let's not forget about energy efficiency. While safety is paramount, it's also important to consider the energy efficiency of AHU. Inefficient AHU can waste energy, increase operating costs, and contribute to environmental pollution. Therefore, it's essential to select energy-efficient AHU and to operate them in an energy-efficient manner. There are several ways to improve the energy efficiency of AHU. These include using variable frequency drives to control fan speeds, optimizing airflows, and implementing energy recovery systems. You can also improve energy efficiency by regularly maintaining AHU and by replacing worn or inefficient components. When selecting new AHU, look for models that are certified by reputable organizations such as the Air Conditioning, Heating, and Refrigeration Institute. These certifications ensure that the AHU meets certain energy efficiency standards. Now, let's discuss the coordination with other trades. AHU installations often require coordination with other trades such as electrical, plumbing, and fire protection. It's essential to coordinate these activities carefully to avoid conflicts and to ensure that the installation is done safely and correctly. For example, electrical contractors need to provide power to the AHU, and plumbers need to connect the AHU to the water supply and drain lines. Fire protection contractors need to install fire dampers and smoke detectors. It's important to have clear communication and coordination between all trades involved in the installation. Hold regular meetings to discuss the project and to identify any potential conflicts. Also, make sure that everyone has access to the latest drawings and specifications. By coordinating your activities effectively, you can ensure that the AHU is installed safely, efficiently, and in compliance with all applicable codes and standards.